Yeah, it looks like we've got about 7 people. We'll give it another minute or so here. All right, so hey, all you cool cats and kitties, let's get on with our math one. I decided I better set up something here at home so that if they do shut down campus, we're not stuck scrambling that day. So we'll see how this goes. I'll probably put a thread up on the discussion board on Canvas, get your feedback on it. If it seems like it'll work, okay. If maybe like WebEx is different or will be better for you, we can try that as well. I certainly want to, do what's going to be most conducive for you guys. One of the limitations we're going to have here is I'm stuck just as one whiteboard. So typically you guys would come in, I would have everything written down for 2-7 and 3-7. That's what we're covering today. But not so much here with this. So my plan is this will be the information you need to know for 2-7. We'll work the 2-7 questions. And then I'll write up the information for 3-7, talk to you guys a little bit about that, and then we'll work the questions for 3-7. So for 2-7, this is our inverse function, well, finding inverse of a function. And in order to be able to do that, the function has to be 1-to-1, meaning we use the horizontal line test. If we can draw a horizontal line and hit the graph only once, then the function's 1-to-1 and it would have an inverse function. So for example, my square root function looks something like that. Any horizontal line is only going to hit it one time. So that one would be 1-to-1. But if I have my parabola, if I draw some horizontal line, it's going to hit this graph more than once. Therefore, it is not 1-to-1. We would have to put in some restriction, like, for example, x is greater than 0. So if it was just the right half of that graph, then in this case, it would be 1-to-1 because a horizontal line will only hit it once. This guy here, so the second part. So we're going to have these concept questions again. This is going to be one of the concept questions. How is the domain of f of x related to f inverse of x? And they just swap. So for example, let's say that I have some function f of x and the domain is all real numbers and the range is -1 to +1. So the inverse function, if this was 1-to-1, the inverse function is going to have domain -1 to 1. So I didn't even tell you what the function was, what this thing looks like. It's just these guys are always going to swap. So whatever I have for the range of the base function is the domain of the inverse function. And similarly, whatever the domain of the base function is the range of the inverse function. So they just swap. That's it. So that's what you're going to need to know for the concept questions. How are they related? Well, the domain of f of x is the range of f inverse. And the range of f of x is the domain of f inverse. So that's really important to understand that. If we have a function, how do we find its inverse? Well, we set the function equal to y, solve for x, and then at the end, switch our x's and y's. Now, some of you may have had instructors in the past that had you switch the x's and y's right away and then solve for y. That's fine. If that's the way you learned it, don't go changing it on my account. And then the last thing from 2-7 here is the graph of these functions. So f of x and F inverse of X are related in a graphing, and here's your concept question number 2 from here. They're related because they're just the reflection of each other on y equals x. And y equals x is the 45-degree line. So if I do have the square root function, the inverse of this would just be if I was able to fold this board in half, where does this line end up? And it would be that guy there. And I think in the videos I told you guys, if you're not sure, fold your paper at a 45-degree line and hold it up to the light. If they overlap each other, then you know that you've graphed it correctly. So those are the concepts, or those are the ideas that you should know from 2.7. As I said, we'll go through some of the questions here, and then we'll move on to 3.7 after that. So any question on this before I erase it? Of course, if you're just joining a little bit late, you have a question, you can always go back and watch your video later. But otherwise, before we go on, if you do have a question, again, just type the 3 exclamation points. I know that means, all right, hold on, don't move on until you ask your question. Otherwise, I'll keep moving on here. All right, so I'm assuming no questions. So for 2.7, you guys had asked about number 7 and 8. So these guys are good. These are exam type of questions. So before I get into how do we solve this one, so let me write down what it is first. So we have f of x is x minus 2 over x plus 2. So those steps that I told you guys about, those are good for like the x squared, square root function, cube root function. Those will work pretty well on those. With this one, a rational function like we're going to deal with in 3.7, they're a little more difficult. However, they all follow the exact same steps. So I'm going to give you those steps now, and then we'll follow them on this problem and see the kind of answer that it generates. So the first thing, just like before, we're going to set y equals to whatever the function is. So in this case, y is equal to this guy. Step 2, multiply both sides by the denominator. And these steps work for every single type of problem like this. So if you're trying to work these steps and all of a sudden something doesn't work, it means that you must have messed something up in an earlier step. These steps will always work through this way. After you multiply both sides by the denominator, you're going to distribute the y on the left side. Once you've done that, you're going to move all x terms to one side, everything else to the other. So if it has an x term, move it to one side, either the left or right, doesn't matter, it's up to you. So the one side is going to have all terms that have an x in them, so you'll be able to factor out an x out of all those terms. So once you factor out that x, you're going to have the parentheses. So I'm just going to write that as divide by the parenthesis piece. And last but not least, just like before, switch your x's and y's, and that will give you your inverse function. So let me hold on here for a second till you guys get that written down. Once you guys have it written down, just type done so that I know you're ready to move on, so I don't move on without you here. Okay, thanks. Hey, fellas. These are all the steps just, yes, yes. So when we have a rational function like this, so a numerator and denominator, these will be the steps we follow every single time. All right, so let's try that on this problem, see how this works. So first thing, set y is equal to this guy. Step 2, and as I'm going through this, if something doesn't make sense, hit that exclamation point so I know to slow down until you can ask me a question. Step 2, multiply both sides. So when I do that on the right, they cancel out. So all I'm left with now is x minus 2 on the right side. On the left side, step number 3, distribute the y. So I have y times x is xy, and y times 2 is plus 2y. Step 4, move all the x terms to one side, everything else to the other. So I'm going to subtract x from both sides, and you can either move everything to the left or everything to the right. It's your call. So we get xy minus x plus 2y. Those cancel out is equal to negative 2. And now subtract 2y. So you have xy minus x equals negative 2y minus 2. Step 5, factor out an x. If you try to factor out an x and it doesn't work, then you've goofed something up above here. Because at this point, we should be able to factor out an x from one of the sides. Now we have this parenthesis piece, that's number 6, so divide everything by y minus 1. And then last but not least, this is not f inverse of x. F inverse of x has to have only x variables. So we need to change these out. So f inverse of x is just negative 2x minus 2 all over x minus 1. So I think that's the right answer. Is there any way, so if this is on a test, before I hit that submit button, if I want to know if in fact I've done this correctly, is there any way to figure out if this answer is right or not? And if so, what do I do and what is it that I'm looking for? Exactly. So we can do it either way. We can either plug this into the original and then simplify, and it should equal just x. Or vice versa, if we plug the original into the inverse and simplify, it should equal just x. So yes, thank you, Nathan. That's perfect. If it doesn't, if you plug this into the original and simplify and you end up with x plus 1, then that's not the inverse. You did something wrong. So that's the way you'll always be able to check. Does that make sense to everybody before we move on? All right, I'm going to erase this. All right, so the next one, the question on similar, number 8. You have f of x is equal to 2x over x minus 9. So go ahead and try this one. Grab a chair here and sit down for a second. So try this. If you do get stuck or you have a question, feel free to type it on here. I'll answer it as best I can. That's where maybe the WebEx would be a little bit better because I know you guys can actually communicate vocally with me, but we'll see how this goes. If we need to switch it up, I certainly am open to that. As I said, I'll probably put like a discussion thread on Canvas. So if you guys have questions, you can always post it there. And once you guys get done with this, just type done. So that way I know that you guys are getting finished up and make the best use of your time. Okay, good. So is there anybody outside of Nevada that's watching this? You guys moved back home somewhere? I know I had my earlier class, Hawaii and Guam, actually. So anybody on like really crazy hours watching these videos? Still in Vegas, okay. At least we got a nice day today, although we have to be inside doing these videos. But maybe as it gets warmer, I'll start filming these from my back pool deck and enjoy some of the sunshine. We'll have to see. So again, as you guys finish up, just make sure you put done so that I know everybody's wrapping up with this problem. Okay. Okay, Daryl. Okay, Andrew. Is everybody else still working, I'm assuming? I'll give you guys about another minute here or so. Okay. All right, so let's look at this one. So again, we're going to put a y into the equation. So y is 2x over x minus 9. Multiply both sides by the denominator, the x minus 9. And now we have to distribute the y. So xy minus 9y is 2x. So here you have the option. You can either move all the x's to the left, or if you want to move the xy over, subtract xy from both sides. So you have 2x minus xy. Step 5, factor out an x. So you're left with 2 minus y. Then divide everything by the parenthesis piece. So we get x is equal to negative 9y over 2 minus y. So then go ahead and switch our x's and y. So f inverse of x is equal to negative 9x. And then 2 minus x. Now, you may not have the same answer. Reason being is, depending which way you move your x's, if you move them to the left, you'll get the opposite answer here. So this is your answer, or the answer would be 9x over x minus 2. So if you get either of those answers, they're both correct. It's just depending which way you moved your x variables in step 4 will cause the answer to look one way or the other. So questions on that? All right, so that was it for 2.7. For 3.7, and so we kind of jump way into chapter 3 here because we're talking about rational functions, which is what we sort of just got done doing there. So in 3.7, we have something that looks like this. So r of x is equal to a to the n, x to the n, plus a bunch of stuff, and then a 0, some constant, and then b sub m, x to the m, plus a bunch of stuff, plus some constant in the denominator. With these type of problems, you will be asked potentially 7 different things. First of all, what's the x-intercept? Second, what's the y-intercept? Third, what's the vertical asymptote? Fourth, what's the horizontal asymptote? Fifth, what's the domain? Sixth, what's the range? And then 7, sketch it out. So those 7 different possibilities. So let me give you exactly how you're going to find those different values. So first of all, to find the x-intercept, you're going to set the numerator equal to 0. So technically you would set the whole thing equal to 0, but then when you multiply both sides by the denominator, you're just left with the numerator equals 0. There's no reason to go through all that extra work. Just set the numerator equal to 0. The second piece of information, y-intercept. We're going to set all the x's in the equation or in the rational function equal to 0. Step 3. For the vertical asymptote, we set the denominator equal to 0. So we want to find out when is this thing undefined. That's our vertical asymptote. And fourth, horizontal asymptote. So for this one, I'm going to put it depends. And it depends on the following. So for the horizontal asymptote, first, if m, well, let's do it again. If n is less than m, so if the exponent in the numerator is less than the exponent in the denominator, then the horizontal asymptote is just y equals 0. So vertical asymptote is always going to have the equation x equals something. Horizontal is always going to be y equals something. So in this case, if the exponent in the top is bigger than the exponent in the bottom, the horizontal asymptote is just the x-axis, y equals 0. Second, if n is equal to m, so if it's x squared in the top and x squared in the bottom, then the horizontal asymptote is just a sub n over b sub m. So this coefficient divided by that one. That's it. Nothing tricky about that. And lastly, if n is bigger than m, so if I have x to the third in the numerator and x squared in the denominator, there is no horizontal asymptote. So we could have what's called a slant asymptote, but the key here is just there's no horizontal asymptote. Once you have these 4 pieces of information, it's easy enough to sketch this graph. You can put the asymptotes on, you can put the X-intercept, Y-intercept, and you know where to draw the graph. Once you have the graph sketched, then it's easy to figure out what's my domain and what's my range. And I'll give you these little hints. So the domain is all but the vertical asymptote. So if my vertical asymptote is -1, then it's negative infinity to -1 union -1 to infinity. It's everything besides the vertical asymptote. And the range is all the values except the horizontal asymptote. So if my horizontal asymptote is y equals 5, then it's going to be negative infinity to 5, union 5 to infinity. We jump that asymptote, and that gives us our domain and range. So any questions on that before we continue? All right, so let's look at some of the problems you guys had here. So the first one is number 8. And we have r of x is equal to 6x to the third minus 2 over 2x to the third plus 5x squared plus 7x. And it wants to know the horizontal and the vertical asymptote. So for horizontal asymptote, we're looking at the exponents. X to the third and x to the third, they're the same. Therefore, the horizontal is what? It's just this value 6 over this value 2, which is y is equal to 3. So your horizontal asymptote value that you would put in your box on WebAssign is just 3. So for the vertical, what do? Well, we set the denominator 2x to the third plus 5x squared plus 7x. Set that equals 0. So I can simplify this, pull out an x. I get 2x squared plus 5x plus 7. And now I can do zero property rule. So x is equal to 0. And 2x squared plus 5x plus 7 is equal to 0. Now, one of the things by jumping to 3, 7 is that we skipped over the complex numbers. We're going to go back to them in section 3.4, maybe 3.3 or 3.4. But this one does not give me any answer. I can't plug any real value of x in here and get an answer. So in this case, your vertical asymptote is just x is equal to 0. Questions on that one? All right, again, if you have questions, just type that exclamation point. So let's move on to number 9. So number 9, we have r of x is equal to x to the third plus 3x squared all over x squared minus 4. So there's two vertical asymptotes, one horizontal, potentially. So let's do the horizontal first again. So with the horizontal, I'm looking at the exponents. 3 in the numerator, 2 in the denominator. When I have the larger exponent in the numerator, what does that tell me I have for an asymptote? So when I have this sort of case, I have an exponent that's larger in the numerator. So it's not y equals 0. That's when the larger number is in the denominator. So then it's the other option, which would be what? Exactly. So no horizontal. When the larger exponent is in the numerator, it means no horizontal. And I think WebAssign says put DNE. So yeah, exactly. No horizontal asymptote. So does that make sense to everybody before I move on? Why we have no horizontal asymptote here? Okay. So now for the vertical. And it says what? Vertical small, vertical large. So just like the test, you have to enter your smallest number in first into that box. So for vertical, we do what? Set the denominator, x squared minus 4 equal to 0. Two terms with a minus sign and an x squared. Oh yeah, that's my difference of squares. So x plus 2, x minus 2. So x plus 2 is 0. X minus 2 is 0. So x equals negative 2, x equals positive 2. So the smaller value is negative 2. The larger value is positive 2. So does that make sense to everybody? Any questions on that before we move on to number 10? All right. Oh, yes question? Or yes, you'd understand it? So I'm going to assume that means yes, it's understood. If you have a question, just type the, oh, no, sorry. Okay, yep, that's fine. Yeah, I figured that's what I meant. So, all right, number 10. So number 10, we have r of x is equal to 4x minus 4 all over x plus 2. Now, before you start this one of the issues we have here, obviously, is I can't really take attendance. Either you guys log in or you don't. Ideally, I want you logging in. I don't know if you guys can see it, but there's only 17 people on right now. 17 out of 40 from the whole class. Maybe some are going to go watch the video later. That's fine if that's what they choose to do. But what we're going to do in lieu of attendance is one time during these live streams, one of the problems I'll pick to use as, well, let's call it the attendance problem. So this one here is the attendance problem. What I would like for you to do is in your ticket out the door notebook, put this problem in first. So for 4/1/2020, the first problem you'll have in there is this one, number 10. And that way, at the end of the semester, when I'm checking your guys' notebooks, this will be what counts towards your attendance. So if you have, let's say between now and the end of the semester, maybe we have maybe 10 days or something like that, or 10 class periods, you should have 10 of these attendance problems. If you're missing any of them, that will start to affect your attendance grade. If for some reason you don't, let's say something happens, you're not able to watch the video during the live stream, at least go back, watch the video, find out, okay, what's the attendance problem? Let me put that in my ticket out the door notebook. So you don't have to buy a new notebook or anything. Just put it on the same date. 4-1, problem number 10 with your work. And then I'll give you 2 more ticket out the door problems here at the end of class. So I'm going to let you work this one. Just follow our logic here. So for numerator, or for X-Intercept, set the numerator equal to 0. Y-Intercept, set X equal to 0. Vertical, horizontal, that should give you the answers you need. So yes, this is the first attendance problem. The ticket out the doors today, let me turn this down a little bit. The ticket out the doors today will be the first ticket out the door problems that you've had since before exam 2. So yes, this will be the first of this type of problem. So go ahead and work these. If you do have a question, go ahead and type it in. So just solve it. Yes, exactly. So just solve this one. So if you want to do this one in your ticket out the door notebook right now instead of your regular notebook, that's fine. If you want to work it and then transfer it to your ticket out the door notebook, that's okay too. But if I was in your guys' position, I would probably just do this one in my ticket out the door notebook already. That way it's there and I don't forget and then lose points at the end of the semester, even though I was, logged in and watching the videos and so forth. Then again, if you don't have a question, once you're done, just go ahead and type done so I know that everybody's kind of finishing up, and then we'll move on here so I don't monopolize too much of your time today. Okay, good. Okay. Right. So again, once you guys finish up, just go ahead and let me know you're done. Otherwise, I'll keep giving you guys a little more time here yet. Okay, good. About half of you. All right, so give everybody a little bit more time here and then we'll work this one. All right, so first off, X-Intercept. So X-Intercept, we set the denominator. So 4x minus 4 equal to 0. So 4x is equal to 4. That means x equals 1. So as an ordered pair, it's always going to be whatever our value for x is, in this case 1, and y for 0. That's our X-Intercept. For Y-Intercept, we put 0 in to this rational function anywhere we have an x. So 4 times 0 minus 4 over 0 plus 2. So these guys are just zeros. So I get negative 4 over 2 is negative 2. So as an ordered pair, it's going to be x is 0, y is negative 2. Vertical asymptote. Set the denominator, x plus 2, set that equal to 0. So move the 2 over. So we have x is equal to negative 2. So that's my vertical. And last but not least, horizontal. So for horizontal, this is where we have to look at the exponents. So this is x to the first power, x to the first power. So they're the same. So it's just going to be y is equal to 4 over 1. Or in this case, y is equal to 4. So any questions with that? Did you guys all get that? Or any issues with that? Because what I want to do is continue this problem, even though I know it didn't ask what's the domain, what's the range, and sketch it. I want to do that on this problem and show you what it is or how you would do it. So, given the information that we created here, so we have what? Our X-intercept is at 1, 0. So right here, meaning the graph is going through that point. And our Y-intercept is 0, negative 2. So 0 units left or right, 2 units down. So the graph is also going through this point. And then our asymptotes. So vertical asymptote is going through x equals negative 2. So over here. And the horizontal is at y equals 4. So up here. So now if I'm going to sketch this, well, I know the graph has to go through these 2 points. And I know that these rational functions look like the 2 curves sort of reflecting on each other. So I know I have one graph here, not drawn very nicely. But then the question is, okay, where did the other part of the graph go? Well, could I have part of this graph? So if this asymptote keeps going on forever, could I have part of the curve in that upper right? And the answer is no. Why? Well, if I did, what's happening? This is hitting the y-axis, meaning I have another y-intercept. I don't have 2 y-intercepts. I only have 1. So the graph can't be up in that section there. What about down here? Could I have a graph down in this section? And same reason, the answer is no, because then it would be hitting the x-axis, meaning I have another x-intercept, which I don't. I only have 1 in this case. So nothing there. So the only other place this could be, whoops, not a dotted line, solid line up there. So if you were asked to sketch this graph, that's what the sketch would look like. And now that I have the graph drawn, I can figure out the domain and range. So the domain is what? It's all my x values. And it's everything from negative infinity all the way to positive infinity except for what? Except for where I have my vertical asymptote. The vertical asymptote is at -2, so the domain is going to be -infinity to -2 union -2 to positive infinity. So I'm hitting something, hitting something, hitting something, jump the graph, and then I'm hitting something again all the way to positive infinity. Any questions on that concept before we do the range? All right. Range, same idea. So it's everything from -infinity. I'm hitting something until I get the horizontal asymptote. I have to jump that. Then I start hitting something again. So it's everything except 4. So -infinity to 4 union 4 up to infinity. Any questions on that? All right, so let me have you try number 11. X is equal to 2x plus 6 all over -6x plus 3. So go ahead and try this one. I hear the ice cream man outside. I don't know if you guys can hear the funny music playing. Maybe I'll go grab some ice cream while you guys do this one. I'm just kidding. I'm not going to get ice cream. Summer's coming. Got to cut out the sweets for a while, I guess. So go ahead and try this. Again, find your asymptotes, find your intercepts. Once you guys have it, just type done so I know you have it, and then we'll work this one as well. Get one of those. Yeah, exactly. I always used to get either the bomb pops, like the red, white, and blue ones, or the Mickey Mouse ones, like the chocolate and vanilla with the chocolate coated ears. Don't even know if they have them anymore, but SpongeBob doesn't sound too bad either. All right, Daryl, that was quick. That's good. Hopefully you're got these guys dialed in. That's good. Okay, good. I assume so since nobody said anything, but just want to double check. And this you don't have to find domain and range and sketch this one. I think it just was asking for maybe you had to sketch it, but I think you were picking one of the four pieces out. So okay. Okay, Shelby. Okay. Okay. Everybody else still working? Okay, is 11. No, so just number 10. Number 10 will be the only one in your ticket out the door notebook. Like I said, if you want to write attendance by it or something, so later on, if you're reviewing and you're like, why do I have this problem in there? It's just a reminder like why it is that you have it. But just number 10 is the only one that has to go in the notebook. Everybody else done or still working? Okay. All right, so let's go ahead and figure this one out. So our X-Intercept, same idea. Whatever the numerator is, 2x plus 6, set that equal to 0. So 2x is equal to negative 6, divide everything by 2, x is negative 3. So the X-intercept is going to be negative 3, 0. For the Y-intercept, set your x is equal to 0, so 2 times 0 plus 6. Negative 6 times 0 plus 3. So you get 6 divided by 3, which is 2. So 0, 2 is your Y-intercept. Vertical asymptote, set the denominator equal to 0. And again, these are the concept questions from this section. How do I find X-intercept? Set numerator equal to 0. How do I find Y-intercept? Set x equal to 0. How do I find vertical asymptote? Set the denominator equal to 0. Negative 6x is negative 3. Divide everything by negative 6. X is equal to positive half. And then horizontal, it depends on the exponents. So they're the same. Therefore, it's just the ratio of these guys. Y is equal to 2 over negative 6. If I simplify it, y is equal to negative 1/3. So any questions on that? Any of those 4 pieces of information? Hopefully, this makes a lot of sense to you now, and you're like, boy, these are pretty easy. And on the exam, these will be easy points for you. If something doesn't make sense or something doesn't seem easy, go ahead and ask me now so I can try to explain it, before it gets to be exam time. All right. Any other questions? Otherwise, I'll give you guys a ticket out the door. Time is it 3:30 almost? Okay. All right. So your ticket out the door today, you have 2 problems. So obviously, these aren't going to be the typical procedure. There's no door to leave. You're not going to show me anything. So I'll give you the problems. I'll give you a little bit to try to work it if you want, because we have some time here. I'll go grab Cash. You can meet Cash today, I guess. I'll give you the answers, but please do work these. If you have an issue with them, either ask on the discussion thread or ask during the next live stream. Maybe the start of next live stream, I can go through those if you have any issues on these ticket out the door problems. Otherwise, at the end of the semester, I'll probably work them on video again, but I'd rather you don't wait till the end of the semester to learn it. If you can figure it out now, it'll make life easier on you. So the first one, so this is our ticket out the door problems, really more of a review problem. So the first one, oh, before I forget too, there will be an assessment due this Sunday, and it will be over 2.7 and 3.7 stuff we've done today. Plus there'll be a few questions on some of the problems that were an issue on exam 2. If you guys struggled on it, I'll put another one on the assessment just to make sure that you guys are figuring these out before we get too far into the semester, or too close to the end of the semester now, I guess. Number 1, find the inverse of square root of 2x minus 1, and then state the range of f inverse of x in interval notation. And then 2, given f of x, or sorry, r of x is equal to 3x minus 4 over 2x plus 1, find the following. Find the x-intercept. Find the y-intercept. Find the vertical asymptote. Find the horizontal asymptote. Find the domain, or state the domain. And state the range. So go ahead and give those a try. Like I said, I'll put the answers up here in a few minutes after you guys have a chance. You guys want to meet Cash? Anybody want to see the old man? Cash, come here, bud. Cash. Cash. Come on, bud. Come on. Want to meet the class? Okay, come over here. All right, so here's Cash. No, come over here. You gotta stand up. Put your feet there. There he is. My little boxer pity mix with his frosted face. Hey, look up here. There you go. Okay. I'll get you a treat later. Okay, go ahead. So, you guys can meet Ginger and Bambi later on, I suppose. So, anyways, try these out for a few minutes. I'll give you guys the answers. Like I said, yeah, he's a cutie boy. He's a good boy. All right. So, for the first one, the f inverse of x is x squared plus 1 over 2. Yeah, thank you guys. And then the range of f inverse is what? It's the domain. Oh, so if this is f of x, it's the domain of this guy. So what's the domain of this one? It's 1/2 up to infinity. So that's the answer for number 1. And then number 2, x-intercept is 4/3 0. Y-intercept is 0, -4. Vertical asymptote, x equals -1/2. Horizontal, y is equal to 3/2. And then the domain, again, everything but the vertical. So it's -infinity up to -1/2. Union 1/2 up to -1/2 positive infinity. And the range is everything except the horizontal. So -infinity to 3/2. Union 3 halves up to positive infinity. So again, we still have plenty of time, about 15 minutes here or so. If you guys want to try to work those, that's fine. If you have questions, I can try to answer it through the text here. You can type it out and I'll try to answer it if you have questions. But otherwise, those should be the answers you get. F inverse is x squared plus 1 over 2. Yeah. F inverse, the range, 1/2 to infinity, because that's the domain of the original function. And then all this information for your rational function. Otherwise, if you guys don't have questions, you're free to go, obviously. And have a good weekend. Stay safe. Talk to you guys on Monday. I will probably put up a discussion thread again, just getting feedback now that we've had a chance to do some review, an actual sort of quote unquote class. Get your guys' feedback on it and be honest. If it's negative feedback, that's fine. I'm not going to dock your grade because, oh my gosh, they didn't like how something was being done. I want you guys to get the most out of this. So the more feedback I get, the better I can make this for you guys. So otherwise, have a great weekend. And again, I'll still be on here for 10 minutes or so. So if you guys are working this and you have questions, if you didn't get the same answer, maybe I can try to help you. But if you do leave, certainly have a good weekend and be safe. Thanks, Amber. Yep, Cash will probably be sleeping all weekend, so that's like perfect weekend. Thanks, Nathan. You too. Thanks, Brianna. You too. Thanks, Daryl. You too. Have a good weekend. Thanks, Vanessa. You too. Have a good weekend. Stay safe. Like we're down to the last couple of people. You guys have any questions? Otherwise, I'll shut down the live stream. But if you guys have a question, go ahead and hit exclamation points. I'll see if I can answer it for you. All righty. I'm going to shut it down then. If you guys do have any other questions, go ahead and post it on Canvas. I'll try to answer it for you there. Or if you want to ask it on Monday, I can certainly try to answer it then as well. Otherwise, you guys have a good weekend. Talk to you soon.